right, so now how about we make it really tricky and a little bit challenging. And let's say we park our car on a hill. All right, we're gonna take our car. It's a pretty steep hill. And let's give this an angle of something like 20 degrees. Pretty steep hill. If all goes well, the car will stay at rest and the forces acting on it will remain balanced. So these are the forces that are going to be gravity. So here's our car. We have Earth over here, and it's going to be pulling down with the force of gravity. And it's sitting on a surface, so we have our hill. So sitting on a surface, and we have normal force pushing up at that perpendicular. And then we also have, since it's on an incline, we would have to have friction keeping it there. So to draw a force diagram, we would take our car, and we have the force of gravity acting straight down. The normal force is going to be perpendicular to our surface, so it's going to be, hold my paper still, there we go. It's going to be at roughly this angle. This is not to scale, but we have our normal force going up this way. And then friction, so if the car were to start moving, it would be going this way. So friction has to be acting opposite of that motion. So it's going to be acting parallel to the surface. So that's going to be our force diagram. So let's find, let's just find all of the forces, shall we? So let's start by writing our sum force equations. So we have, what we normally do here is we draw this y-axis going this way and our x-axis going this way. So the sum force equations that we have here, it's pretty light. We have the sum of the y forces are going to be the force of gravity. It's going to be the friction force, but not just the friction force, but the y component of the friction force. And then also the y component of the normal force. Now our car is at rest, so those are still going to be equal to 0. And then we have our x forces, so the forces acting in the horizontal. We have part of our normal force, so the x component of our normal force, and we have the x component of our friction force. And again, those are balanced. So that looks pretty terrible, but let's see if we can find anything out. We know we can find the force of gravity if we know our mass. Let's just say we have a 1,200 kilogram car. We'll give it the mass of that. So we have a 1,200 kilogram car. We're going to multiply that by our gravitational constant. So we're going to have a gravitational force of 12,000 newtons. Now, does that help us? Let's see. Force of gravity is in our y equation. We don't know friction, so we can't find this, and we don't know normal, so we can't find this. So, these two things are not equal. So we've got a normal force and we've got a friction force. Those are not necessarily equal forces. They could be, but they might not be. So we can't say that these two things are equal to each other. So we can't really solve this equation. We can get a little closer, but we can't. We know that the y component of our friction force and the y component of our normal force are going to be equal to the gravity, but we don't know how much of each one that is. So what about our x equation? Same thing. We don't know our normal and our friction. So we can't really solve this equation either. So is this problem even solvable? Well, let's talk physics secrets for a minute. So remember way back when we first started talking about reference points and how we said you could define your reference point however you wanted to. Well, it turns out you can do the same thing with your coordinate planes. Your y-axis does not have to go straight up and down. Your x-axis does not have to go straight across. So let's draw a new force diagram here real quick. got our force of gravity going this way, and we still have our normal force going roughly this way, and then our friction force. Okay, so what we're going to do is we are going to take our coordinate plane and we're going to line it up so that the y-axis lines up with the normal force. So this right here is going to be our y-axis. So then where would we put our x-axis? Well, our normal force is actually, something. It's perpendicular to the plane, and our friction is going to be parallel to our plane. And so our x-axis is going to be at a 90-degree angle from our y-axis, which just happens to line up with our force of friction. So now what we have is we have this y-axis moving in the same direction as our normal force, and our x-axis moving in the same direction as our friction force. That gets rid of these components up here. So this force of friction, x and y component, and this force of normal, x and y component, those are gone now. Now we do have now an x component of our gravity, but if we draw our line, if we draw our triangle so that it goes perpendicular to the y-axis, the angle that the force of gravity makes with the y-axis is the same as the angle of our incline. So let's rewrite our sum force equations to reflect that. We have the y forces. Now our normal is straight up and down, so it's the total normal force plus the y component of our gravity. And those added together are going to be 0, because again, we're still not moving. And then we have our x equation is going to be the force of friction plus the x component of our gravity. Now this is nice because now we have some components of gravity in both of our equations. And we know gravity. So we found the gravity force up here. We found the weight of the car up here. So now what we need to do is find the x and y component of the gravity to plug into our equations. So remember our trig functions. So our angle is 20. So our opposite angle is going to be our x. So opposite is going to be the sine function. So sine of theta is opposite over the hypotenuse, with the hypotenuse being our force of gravity. So the sine of 20 is going to be equal to the x component of gravity divided by the force of gravity, which was 12,000 newtons. So punching that in, we have, to solve for this, we're going to take 12,000 and we're going to multiply it by the sine of 20 degrees. So the x component of our gravity is going to be equal to 4,100 newtons. So then our y component is the adjacent to our angle, which is going to be the cosine. So we're going to take the adjacent over the hypotenuse. So the cosine of 20 is going to be the y component divided by the force of gravity. So we're going to take 12,000, we're going to multiply it by a cosine of 20, and we're going to get the y component of our gravity to be 11,000 newtons. Now how does this help us? So we have our components now. Now if we look up here, our normal force plus our y component is going to be equal to 0. So if our y component is 11,000, that means that our normal force is going to be 11,000 newtons as well. Same thing over here with our x component. Force of friction plus our x component of gravity will equal 0. So if the x component is going to be 4,100 newtons, then our force of friction will also be 4,100 newtons. So now we found our normal force, we found our friction force, and we found our force of gravity. So we found all of the forces just by tilting our axis and finding the gravity.